Hey, what is good, everybody? Welcome back to the channel. Now, in the previous video, we basically set up our own platform layer, added some functionalities to be able to add some customizations to it, like change the cursor, for example. As you guys can see here, we have like a crosshair as our base cursor for this window, and when I move out, it goes back to the normal cursor. So we added some stuff to basically be able to add these functionalities on the fly and so forth. In today's video, essentially what I want to do is I want to start off and create an event system, right? Because you notice that in the previous video when we were setting up, functionalities and abilities to basically handle key inputs, we wanted to basically hook this up to an input system. Right now, an input system, we want our input system to essentially subscribe, well, not really subscribe, but we wanted to basically fire or publish some events, right? Like, so if you click on a button, then the operating system will tell the input system that, hey, a specific button has been pressed, and then the input system will then tell the event system that, hey, I want to publish this specific event, that, hey, the key R has been pressed, or the key shift has been pressed, or the key space has been pressed, or whatever has been pressed, right? Or the mouse has been moved, so we want to fire off that event, and then that event will basically have data associated with it. For example, if we have an event that basically subscribes to mouse movements, for example, our input system will basically send off that mouse movement event, and then whoever is subscribed to that mouse movement event will then be able to get that data from the event system, such as the mouse position and whether or not the left mouse button or the left mouse button is being clicked at that specific position or whatever, etc, 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 right? So that is what we want to set up in this video. So yeah, let's do that. But before that, there was still some stuff that we left hanging here in our platform layer, and that is when we close the window, or well, not when we close the window, but when we destroy the window, we don't have this function implemented, and also we don't have the window hide function implemented. So with the notion of starting with the easiest functions first, I'm going to start off with this guy here on hiding the window. So to do that, all we got to do is take in our window handle here, and just get the state of that window handle, and then inside we want our ns window, and then we want to do some Objective-C stuff here. So we want to tell the operating system that, hey, I want to set the visibility of this window to let's just put boolean here for those who don't know, so that you can know that this is a boolean. So yes is a boolean. It's true or false. I mean, true for yes, and then false for no. Yeah, it's just an Objective-C thing. But anyway, yeah, so what we want to do is when we call window.hide, we just tell the operating system that, hey, take this specific window and set its visibility to to hidden. I mean, so we want to say no here, actually, not yes. So we just want to hide that, and then when we show it, we just say, hey, take this window and then make it the key window and bring it to the front, and that's about it, right? Yeah, so now let's tag up and finish up this one here. So to finish this one, all we want to do is a few things, right? So we want to take our window handle again, so window, and then we want to get the state, so state, and then we want to get the window, right? Because the end is window. And then all we want to do is say order out. This removes the window from the screen list, which hides the window also, right? So I'm gonna basically just say no here. And then all we want to do is take again this handle, this window handle, and then we want to remove the delegate as well. So set delegate, and we want to set that to null. And then we also, actually, let me just duplicate that for a minute, so that I don't have to retype that over and over again. And then also what we want to do is we want to release the window delegate from this window state. And to release that, we just use the release keyword. just to free that memory, right? And then after removing our delegate, we want to basically let me see. We want to what else do we want to do? Yeah, we want to also remove the view. So we also want to set that to null. So window state, and we want the view here, and we want to release memory for that. And then all you want to do next is just duplicate this and remove this bracket over here, and then just say view is equals to null. Okay. And then next, all we want to do is, let me just copy this once again, create some spacing here just to keep things nice and neat. Instead of the view now, we go back to window, and then we want to say close, removes the window from the screen. So yeah, we just want to make sure that it is actually gone. And then from there, all you want to do is window state no, actually no, we actually covered the view, so it's okay, fine. What else do I want to do here? Oh, we actually want to remove this window from the list of windows that we have in our internal state. So windows, and I want to take the first window, and then we want to set that to 0. Now the reason why I'm doing it this way, oh yeah, actually our internal state is not a pointer, so yeah. And what I'm doing with this is essentially I'm just assuming that we only have one window in this list for now, because our platform layer supports multiple windows, right? However, for now, for the time being, we only have one window to work with. So that one window will always be at position 0 unless specified otherwise. But it's safe for us to just assume that we only have one window, and we set that position to 0 and just nullify it again. So yeah, and then all I want to do from there is actually, yeah, let me first test this before I even do this. So let's run this to see that everything builds successfully, and yes, it does. So what I want to do is, you saw that the window showed, right? So once we show the window, I just want to destroy that window. So platform window destroy, just to test that our function is actually working, right? So I'm going to run this, and yes, we don't see a window. However, our application is still running. You see that? And if you look here in the dock, the engine platform layer is still running, right? So just because we close the window doesn't mean we actually close the application. So we want to close the application when we actually also close the window, the last window, right? So in this case, since we only ever will have one window for now, and we're assuming that we only have one window for now, I'm gonna put a temporary trigger here. Okay, so temporary, do I even know how to spell temporary? Temporary, I think it's spelled like that, temporary. Yeah, I think that's right. So I want to put a temporary trigger here to basically trigger the application to quit, right? So we're gonna say should close, and I keep on forgetting that this is not a pointer, so should close equals to true. Now with this bit of line, you'll notice that when I try to run this, it'll create a window, then automatically destroy it immediately because of this line. And after it destroys that window, it's gonna hit this trigger right here, which says should close is equals to true, and that basically exits the application. And how is that happening? That's because in our main file, in our main C file, we have this while loop that relies on window on platform should close. So when that is true, then it basically kicks us out of this while loop, and then it hits the platform shutdown, and that basically, closes our application, right? So yeah, so now that we have these two functions filled in, we can now start with our event system. So I'm going to create two new files. Actually, I don't want them in my platform. I want them outside of that. but in the root directory. So I'm gonna do new group, and I'm gonna call this core. Okay, and then inside of core, we're gonna have core files, right? So we're gonna have an event system. Okay, so we're gonna do engine platform. Yeah. Just click OK. Then we're gonna have an event header file. So inside our event header file, we're gonna start up our logic, right? Our structs and everything that we need for our event system. So like I said, our event system is gonna be able to basically register events, right? And the basic types of events that we're gonna be basically passing around will be data, right? Such as mouse clicks, mouse movements, keyboard clicks, just those basic primitive types, right? Did I say primitive? Just those basic data types, right? So we want to basically have key codes, event key codes, and we also want to have what is this, event data, to basically pass data around. Okay, so the key codes will be used to essentially it would be like you know what, let me just give you an example. So let me just type this out first. So type dev enum so that you guys can see what I'm talking about here. So event code, and then we're gonna have like an event code here, like key pressed, right? So this is our key code. Okay, so this key code, right, is what we will be basically listening for. Okay, so am I explaining this correctly? Man, I haven't done this in so long. Yeah. Well, essentially, we're gonna have key codes, right? And then we're gonna listen for those key codes, right? So for example, we're gonna publish an event, and then that event is gonna have this specific key code. For example, the event will be like on key pressed. Then we're gonna listen for an event called on key pressed, right? And then basically have like a callback, which will then basically, you know, call whatever function that we wanted to call to basically handle that key pressed event, right? So yeah, hopefully that makes sense. I don't know, but yeah, my mind is not in the right place. If you look at the time up there, it's actually 1 a.m. on Monday. So again, I'm very tired. I should be sleeping, but I'm here coding. Yeah, so anyway, that's what we're gonna do, and then we're gonna have what is this, an event data struct here, so to basically pass the data around that we want to pass around. So this is going to be called event data, okay, which is going to hold a union, right? And then within this union, we're going to have the data that we want to basically pass around with our events. So we're going to basically just create a bunch of vectors or arrays or whatever you want to call it. So I'm going to start off with an i64 and then i64 like this, and I'm noticing that I'm not getting IntelliSense for this. That is because we don't have include. Where is our defines? This should actually move out of the platform. Interesting. Yeah, this actually should be moved out of here, but for now it's fine. I'll just leave it in there for the sake of simplicity for now. But we will do a proper cleanup soon enough, so it should be outside. So platform defines.h, okay, and that will give us that i64. Okay, so this will hold two items, x and y, and then we're gonna have let me just duplicate this. Then we're gonna have a u64. This will also hold two items, and then we're gonna have like a f32, which will also hold two items, and then from here onwards we will have an i32, and let's do i32. This one will hold four item, so XY, width, and height, right? That's an example of the data that you can pass with this. So then we're gonna have a U32. Okay, that will also pass in hold for elements, and then we would maybe have, let's see, I64, U64, F32, I32, U32. I guess we might as well just go ahead and do an I64, an I16. Call that I16, and then that should basically take in about 8 elements, right? And then we're gonna do a U16 here, and then that should take in 8 elements as well. And then I16, U16, and then the last one should be I8. I8, BMW I8. And that one should take in about 16 elements. And then we should have U and U. Yeah, and then that's it essentially. And then we also want our event system to be able to handle dynamic or custom data. So we will basically have another union within this union, and that one will hold a U32 of size, and then we're gonna have basically a void pointer that points to that memory, right? To that data. Yeah, and then we're just gonna call this custom data in case you just want to pass custom data that does not conform to this. So yeah, and then we also want to have the ability to pass in strings or whatever, right? So const char, and then it'll just be a string, so just like that. And then we want to name our union, and we want to name that data, so event data. Okay, so now that we have our event data struct, we want to have our methods to go along with this. So let's do event system slash initialize. Okay, then we do event system shutdown, and these will take in nothing, so those will be void. And then we will have the ability to basically subscribe to an event, so we will just say event subscribe like that, right? And then we will have event unsubscribe, okay, to unsubscribe to a specific event, right? And then we also want to be able to basically publish an event, so event publish event, right, which will then publish the event to all the subscribers that are basically subscribed to a specific event. So I think this is all that we will need for our input, for our event system. And how do you want to send the event? How do you want to subscribe to an event? So again, I said that our subscribers will basically be listening to these event codes, right? Or subscribing to these event codes. So we want to take in a U16. And in fact, let me do this integer. Well, can I say U16? U16 like this. Let me build this real quick. I guess we good. Okay, yeah. So this will be a U16 code. That will be this event code, right? So we're gonna have more event codes, but I don't want to deal with that right now. Okay, then we are essentially gonna say void. We're gonna have a sender, right? No, not a sender, a subscriber, right? So it's gonna be a U16 code that we're gonna be basically subscribing to, and then we're gonna basically have the subscriber. This can be null. The subscriber can be any function, right? So yeah, and then we want a way to basically have a callback. So we're gonna have an on-event callback, and I'm thinking that we should basically let me just come up here. Should I? Yeah, let's just do a pointer function. It's gonna be return a boolean, and then we're gonna call that. I'm gonna stick with how. Is it Vulkan that does this? Pointer function on event. Okay, then this pointer function is gonna have the following signature. So a U16, which is the code, and then we're gonna have a void sender here, and then a void listener, and then we're gonna have event data. Okay, so we're gonna be able to pass in that data to this callback. So this will be a PFN on event, like so. Okay, now that we are able to subscribe, we also want the ability to unsubscribe using the same signature, right? So yeah, that's about it. Okay, and then to publish, all we need to do is also use the same signature, but whoever is sending it will be passed through here. Okay, like so. Sweet. And I think this is about it. Yeah, this is about it. So let's just copy these guys, and yeah, let's come down here, and then within this implementation file, C file, we are going to set up some state, some global state, or specific to this file, essentially, to basically keep track of our events that are basically registered and our subscribers and so forth, right? So I want to yeah, so let's do a type def here. Struct. Yeah, I'm really tired, by the way. So let's do a subscribed event. We want to have a subscribed event. This subscribe event will have a subscriber, so someone that subscribed to this event. So we're gonna have a subscriber, and then we're gonna have a callback, which is going to be our PFN on event. It's gonna confirm to that signature, and it's gonna be called callback. Okay, and what is this complaining about? Okay, let's do that. So we have a subscribed event which has a subscriber and the callback registered with that, and we're gonna need to have another struct here which will basically have, let's see, how do I want to do this? Subscribed events. It'll basically what do I want to call this? Let's just call this event code entry. Like, again, I say that we basically just subscribing to these event codes, right? And listening for them. So event code entry, and then we're gonna have a list of subscribed events. So we're gonna call that events, and then we're gonna hold a size t of the count, along with a size t of the capacity, and then let's just close our struct here. And I actually should keep the same coding style here, because I noticed that here I only have this there and not up here as well. So I actually just want to keep this consistent. So let me run this quickly and see that we didn't break anything, and that is good. All right. So yeah, I just like to keep things consistent, I guess. Okay, so now what do we want? So let's see. Events code count capacity. We want to also have a struct, so type def struct, for the event system state, right? So the event system itself. So event system state. Let's give that a capital S. And then event system, close that off like that. And then we're basically going to have this guy in here. And then we're going to have subscribed. Okay, and then we're going to have how many events do we want to have? Let's create, let's just do this. Define max message codes, and let's just say 100 for now. So max message codes, like so. Okay, now we want to initialize our event system. So to do that, I guess we're gonna need to have a static event system state. Let's put this like so, and I'm gonna make this a pointer now. I'm gonna call this iState. And then we want to basically allocate memory for this. So if iState, let's do a sanity check to see if it's not initialized, then we need to initialize it. So we're gonna say iState is equals to malloc, which I don't have. So let's come up here and then let's do an stdlib. Sorry about that. Right there, and then malloc. And what we want to do is say a size of event system state, right? Like so, and just for good measure, cast that to an event system state. Sweet. So after we've done that, what we want to do is, let me see, iState, we basically malloc memory for that, and then basically we also want to check now if that succeeded or not. So let's do iState. So if iState, right, if this didn't work, we basically just want to print f something, right? Print f std error. So sorry about that, std error. And I want to basically just say failed to allocate memory for event system state. Sweet. And just because it's a C, let's put a new line character there. And also let's just exit out here with an exit failure. So exit, can I just, there we go. So this is complaining. Oh yeah, this has to be fprintf. Sorry about that. And then next, let's see, what else do we want to do? So we've basically allocated memory to our internal state, right? And then we also want to zero out this, right, that array. So let's do a for loop. So let's say for loop. So int I equals to 0, I less than max message codes I plus plus, like so. Then we want to say iState subscribed. Then we basically want to say I. Then we want to say events. Set that to null, like so. Okay. Then I'm just going to duplicate this about 2 times, and then I'm going to set the count to 0, and then I'm going to set the capacity to 0 as well. Okay, ensuring that we are empty everywhere. So what is going on here? Expected. Well, that's weird. What is going on? Let me just run this because I feel like it's messing with me. But yeah, everything is okay. Okay, so I think that's all we need to essentially initialize our event system and to check that this actually does work. I want to initialize event system before we set up our platform layer. So we can say event. Oh, actually, I need to include this up here. So include core slash event.h, like so. Then I just want to build this real quick. Yeah, and then all I want to do is event system initialize. I wonder why I'm not getting IntelliSense here though. It's kind of annoying. Oh yeah, I window is getting closed every single time you run this, so I guess I need to get rid of this line. I forgot to remove that. Sorry about that. Then I'm gonna save, come back to our main.c file, run this, and we have the application launched, but I don't have any clear indication whether the event system really got initialized or not. So let's go back in this and let's just over here printf something, right? So let's say event system initialized successfully, right? Like so. What am I missing? Oh, like so. Okay, so let's rerun this. And there you go. Event system initialized successfully. Sweet. So, and I just want to put a new line here. Alright, so now we know that our event system is being initialized successfully. All we want to do is also basically shut this down, right? Have the ability to shut it down. So the way that I'm going to do this one is we're going to do a sanity check. So if I state, so if that is basically active, all we want to do is do an integer I is equals to 0, then I should be less than max message counts, basically this for loop over here, and then we're gonna say I plus plus, then we're gonna loop through every single event that we have in our subscribed array. Then we're gonna basically nullify everything. So we're gonna say I state subscribed, then I dot events. We want to free I state subscribed I dot events. So we free that memory, and then we just going to do this and just set that to null so that we don't have like a pointer that's just dangling around, not knowing what to do with itself. So yeah, and just outside of this loop, I want to do a free, and I just want to free the I state as well. So I internal pointer state, because we're basically shutting down the system, so there's no point for it to exist anymore. And we basically set that to 0, or I can just say null, right? Yeah, like that, and just save, and subscribed, no member, subscribed, instruct events, subscribed. I misspelled that. Oh my goodness, where is it? Here it is, subscribed, yeah. Wow, I didn't notice this spelling mistake. Subscribed, yeah. Wow, I'm an idiot. But again, it is 1:30 a.m. in the morning, so it's whatever. So yeah, event system initialized successfully. Shutdown is not being called, so let's go platform shutdown. Let's do event system shutdown like so. Okay. What is really annoying is today I don't have IntelliSense for whatever reason. But okay, I guess, right? Yeah, so we don't have any weird memory bad access stuff going on here, meaning that these two initialization and shutdown methods are actually working pretty fine. So now we can move on to basically implementing the subscribe function, right? To be able to subscribe to a specific event. So within this one, we also want to do a sanity check so that when we call this function, we can only call it when the internal state has been basically allocated and it exists. So if it does not currently exist, or memory for it is not allocated, we just want to return false out of here, and that will basically boot us out. But if this is allocated and it does exist, we can then essentially create an event code entry here, right? And then create a pointer, make it a pointer, and then we're gonna say entry is equals to iState. Okay, subscribed, and I just want to put this, yeah, like so. So what does this mean? This code is coming in from here, right? And again, this code is your event code. So on key pressed, right? So you're gonna pass this in. So you're gonna basically say, I want to subscribe to event code key pressed, right? And then we're basically gonna create an event code entry for that key code, right? And then once we have that event code entry, all you want to do is essentially we want to basically add it to the list. Okay, we want to add it to the list. So let me, sorry about that, I had to go use the restroom real quick. Yeah. Anyway, as I was saying that yeah, we basically need to add the event, or we need to register the event, right? But before we register it to the list, we need to make sure that it's not already registered, right? And how do we do that? So that's why we have this subscriber here, right? So a subscriber, right, can basically subscribe to this event code, right? But we don't want the same subscriber subscribing again to the same event code multiple times, right? So in order to do that, we basically just going to create a for loop here to basically check if that specific subscriber is already subscribed to this code, and basically has the same event code as well. And if so, then we basically just read out a message saying, hey, this event code has already been registered and subscribed to by the subscriber, right? Yeah, we're gonna do something like that, right? So let us try and do that. So let's do a for loop to essentially iterate. So let's do a size t. Again, I don't have IntelliSense. Man, do I need to quit? You know what? I'm sorry for this, but yeah, I know. Let me just close that and try and open this up again. Hopefully it'll work this time. And just run this, and of course it won't run, but return true. Let's see. Return true. Okay, cool, fine, we're good. And then whenever you run this again, did you mean event code entry? Wow, I made a whole lot of spelling mistakes, didn't I? Actually, I want this to be a capital letter. Yeah. And then that should basically exist now, right? unused. Yeah. Okay, cool. Nice. So again, as I was saying, that we want a for loop, and I'm gonna do size t I equals to 0, and I still don't have IntelliSense, but okay, fine. Let's do entry count. Okay, so we're gonna check and iterate through all of the registered events with that specific code. So let's see, if entry events. This really sucks without IntelliSense, by the way. Entry events at I dot subscriber equals to subscriber, like this, and entry slash events dot callback equals to on event, printf, and say that event has already been registered, like so, and then just add a new character line there. And yeah, let's do a return false here, because then the event is not registered, because it is already registered, right? But in case that it's not registered, then let's register it, right? So yeah, so let's do this. So let's add the new event subscription. So yeah, so let's do entry, and then we're gonna do events, then we're gonna do entry count. We're gonna get the index that we want to basically get the subscriber for, subscriber, and then we want to set that subscriber. So subscriber like this, and then I'm just gonna copy these, and then we also want to set the callback for that, and this should be on event like this, and then we want to increment the entry count. So entry count plus maximum subscriber. You know, I don't know why I'm misspelling subscriber today, but it's annoying. Anyway, yeah, let's go to the main.c file, and let's try and subscribe. So event subscribe, and I want to subscribe to event code key pressed, and my subscriber is just null. Yeah, it's just a void pointer, it's just null. And what else? What do I need to pass in? Subscriber, and the pointer event, so the callback, and the callback needs to conform to this pointer function. So essentially all I can do is just take in this function signature and come up here and say boolean, because it needs to be a boolean, and then let's just do on key pressed. So this will be our callback, and it will conform to this signature right there, and then we'll just return true. And in here all we want to do is say printf let's say key pressed, right? Yeah, key pressed, and just add a new line here like so, and here we can just say on key pressed, as our function, as our callback. Hopefully I did everything correctly here. Bad access. So it means we're doing something wrong here. State code is 0. Let's see. Let's debug this. So subscriber, no. On event, I want entry. Events, no. Subscriber, callback. Count is 0. Capacity is 0. So there's no memory for these. Alright, so what do I want to do here? Let's see, what can I do? Let's ensure that we do have enough space to essentially add the subscriber. This event. So what I'm gonna do is that I just above or below here, I'm gonna basically do if entry, we're gonna check if entry count is greater than or equals to entry, because right here you can see it says 0, so the count is 0 and the capacity is 0, so we don't really have memory in it. So if entry count is greater than or equals to entry capacity, so we want to basically ensure that we have enough capacity. So we want to resize this. Okay, so the way that I'm going to do this is I need a resize function because I don't want to type this in here. Let's do one here. So let's do a void. Well, I use it in an if, so let's do a boolean. So resize event entry event array. So event array. How I want to do this? What do I want to pass in here? Let's pass in the event code entry event code, because this is what we have, right? So we want to pass in that event code entry, and we want a pointer to that, and in here we can say size t. I really don't like this because now also my syntax highlighting is really not working. I really don't know why. So I'm going to try and actually quit Xcode. I'm going to stop all tasks. And I'm going to quit Xcode. I'm sorry about that. But yeah, I just can't work like that. I'm tired. And I just don't like having to deal with that right now. Yeah, so there we go. Our colors are back. And yeah, Xcode is finally working like it should. So yeah, so new, we want to basically have a new capacity for this. So new capacity will then be equals to entry capacity capacity. There we go. IntelliSense is not working, right? So we're gonna check if capacity is 0, okay, and if it is 0, right, then we just want to have the capacity be 1. All right, but if it's not 0, meaning it's 1 or more, we just want to double the capacity, right? So I know some of you guys will be like, it's not good for performance. doubling and reallocating an array and whatnot, it's gonna make things slow. But I mean, it's an event system. And also, I'm just doing this so that you guys can see how you can go about doing your own, so you don't have to conform to what I'm doing. So yeah, so let's then do, so after we have the new capacity, we want to basically say subscribed event, because up here, subscribed event, subscriber, and I'll call back in it. So you want to say subscribe events. So events. Actually, let me say new events equals to. Do I want to make mem copy? No. Let's just use our reallocation. So what we want to do, can I see what this takes in? Pointer and the size. So we want to reallocate. So let's do entry events, right? Because event is a pointer, and we want to give that a new capacity times the size of the subscribe event. So subscribe event. Let's just take this subscribe event, size of subscribe event. And I'm noticing some inconsistency within my namings of my structs. Yeah, but I guess I'll deal with that at a different stage, because if you look at this, yeah, let's put a capital letter here because I just like them like that. So that's the inconsistency I was referring to. And because I don't want to confuse it with functions, because all my functions are actually low ladder cased. So yeah. So now we have that. Let's see if this failed or doesn't really exist, then we return false, right? If you failed to basically allocate this, return that to false. Otherwise, entry / events finally has some memory, which then equals to new events, and then entry / capacity finally has a new capacity, which capacity, I just realized I spelled it wrong. Capacity. Capacity. Wow. Yeah. I'm tired. I think I'm gonna repeat that error every single time I make a spelling mistake and blame it on the time, because it's now close to 2 a.m. So yeah. Anyway, I think this function will do. So let's say if we can't resize, so resize event array, and that the array that we want to basically resize, it belongs in the entry, the event code entry, and it will take that, do its magic, and then return. So we've basically ensured, or let's just say ensure there's enough capacity to hold that event. So let's try running this again. Let's see. Bold failed. Where is this? Subscribed events, guys, because I renamed that, and hopefully it works without crashing. Event system initialized. So where is this? Event has already been registered. That didn't get called, so let's try and see if it'll get called, right? So let's try and register this event twice with the same subscriber. So like that, and let's run this again, and it's gonna say event has already been registered. Beautiful. So we now have the ability to basically subscribe to a specific event, right? I think, do I want to deal with unsubscribing, or do I want to deal with subscribing? Publishing first. Let's deal with publish first, right? We want to test the system as fast as we can. So let's do an if statement, do a sanity check. I state, okay, and let's return false here. If not I state, then we don't want to publish anything because there's no state to refer to, right? So we return false, otherwise we return true down here, and yeah, then we do our logic in here. So let's do if. So if there is if nothing is registered for the code, then do nothing, right? Do nothing. So if I state, so if I state subscribed code dot events, so if there's nothing registered under that code, subscribed under that code, we just want to return false, right? So if basically nothing is subscribed for this code, then there's no point, right, of us publishing this event. However, if there is, then we can say event code entry goes to, let's get a reference to that. So let's say I state, let's find that subscribed event that we want, and then let's store it in this event code entry, and we want to do some logic now. So we want to say for size now, let's go with int I equals to 0, and then I less than entry dash count dash I plus plus. So we want to loop through, right? What do we want to loop through? Let's do subscribe event e equals to entry slash events. We want to loop through all the events, right? And then we want to check, okay, if it has a callback, and if it does, then we basically pass in the code that we basically publishing for, right? This code right here, pass it in there to the callback, and then send, and then we basically put in the sender who's basically sending this event to the callback as well, and then we say e dot subscriber e dot subscriber. Then basically all that's left is to basically say pass in some data. So data, and I noticed that we don't have data. So actually this shouldn't be this. This should basically take in an event data, right? Yeah, and then down here publish. Oh yeah, I see, it's the result of copy pasting. Event data. Okay, yeah, it should be like this actually. Okay, so we basically passing in that data to the callback. Okay, and then we can just say message has been handled. Okay, and we don't have to send to other listeners slash subscribers. Okay. What this means is, right, if you notice that we basically have what is our pointer function here? It basically returns a boolean, right? This is our callback. So if it returns true, then we handle it within that callback, right? So back to our main function. So here I'm returning true. So I'm basically handling the event, and then I say true. Then it tells the event system that, hey, we've now handled that event, so no need to send that same event to all the other possible subscribers that could be possibly listening for that same event code. So what I mean by that, let's say, for example, here I have the same code, right? Event key code pressed. Then I might change the subscriber. So interesting. How will I do this? Let's just say void pointer 1, I guess. And then I don't know. Let's do that. Yeah. And then we basically have a different let me just do this. We have a different subscriber. Yeah. We basically have a different subscriber, but they both have the same what is this? They both have the same callback function. So let's see if this will actually work. Subscribe, and yes, it does work. It does register those two subscribe events. So then I want to do an event publish, and I want to publish event code key pressed, right? So I want to say that we've basically pressed on a key, and the data for that, let's do event data. Let's do event data, and then let's just say event data dot I don't know, what do I want to send? Key pressed. So let's just say an I16, and then 0 is equals to, I don't know, 13, I guess, right? And then we basically want to send that data, so event data to the callback, and then in the callback we receive that data, and all you want to do is incorporate that data in our print statement here. So it's a decimal, so I'm going to just say data dot data. I guess that's not really a good naming convention, but we saved that data within an I16 and at location 0. So when I run this now, essentially we're subscribing to the event and then publishing to the event. So then technically, whenever this event gets published, these two listeners will then call this callback here, right? And then it will say key pressed, and it will give me the data, which is 13, printed out. So let's test that. And we do. So key pressed 13. So our event system is essentially working, right? So we basically are able to subscribe to a specific key code and then publish an event using that same key code to subscribers that are subscribed to that key code, and then pass in the data that those subscribers need, right? To do whatever it is they want to do. So for example, for another example, I can copy this and be like, on mouse moved, maybe perhaps mouse moved, and then instead of here listening for key code key press, we can say on key code mouse moved. Now of course we don't have this, so we just need to add it here. So let's do that. Let's say event code mouse moved, and I'm just gonna let that do that thing for me, give it a value for me, and then boom, we have event code key pressed, event code mouse moved, and then instead of this one having a callback on key pressed, it will be on mouse moved like this. And instead of saying key pressed, we can just say mouse moved, like so. And then we can say, instead of data 16, we can have like x, so we can be like, do x, let's say x coordinates of the mouse dash y coordinates of the mouse d. So we can find this in 16i, and then this one will be at location 1, right? And then what we can do is we can do this, okay? And then I can put it here, then I can copy this, move it down here, then instead of key pressed, we say mouse moved. That's the event we want to publish. And then event data 2, I guess, 2 here, 2. Then we can pass in, I don't know, let's just make up a weird number here, and then that will be our mouse position, I guess. So yeah, so event data 2. So now when I run this, you'll see two things happening. So we're gonna have key pressed, and then the key press is 13, and then mouse moved, and then the coordinates of that mouse is at 126.385, which is the data that we're passing through to our callback, right? So this is how our event system will work. Yeah, and then we're basically gonna hook this up with our input system and everything. And then once we have our input system and event system, we're gonna then have an application layer, because we're not necessarily gonna do everything in this main file. We're gonna separate things, and possibly make the engine a library. I don't know, maybe that could also allow us to add like hot reloading and all that cool stuff. But yeah, this is the basic implementation of the event system. Now, of course, we are not done. We essentially implemented the logic to essentially register events and publish events, right? However, what we want to do is we want to essentially unsubscribe from events, right? So let's do that. Let's implement this function, and this one might be a little bit long. So yeah, let's tackle it then. So I'm gonna do a sanity check. Actually, I can just copy this instead of having to retype this all over again. I think I'm gonna return true here at the bottom, like so. And then what we want to do again, we just want to reference to the event that we want to unpublish from. So event code entry, entry like this equals to get the reference to that. So I state subscribed. So we want the code that we subscribed to. And once we have that, we want to check. So let's do if entry events, there's nothing to unsubscribe from. If there are no events registered for this code, we can just return, right? Yeah, we can just return. Actually, there's no need for us to return a boolean. We can just do void, and then we can just do this and this, and let me come to the unsubscribe and just turn this into a void, right? And I think that looks cleaner. Okay, yeah, sweet. So if there are no events to basically unsubscribe from, we do nothing, right? However, if they are, then we want to loop, right? And I guess I'll just do a size team equals to 0. Then we can say entry. We want to loop for how many events they are, and then do I plus plus. Hold on. Like that, and then we want to say entry, right? We want to have events dot, well, not yet, so events dot subscriber. If the subscriber is equals to this subscriber that we want to unsubscribe for, then we will basically capture that event and hold on to it, and then check if that event its callback is also equals to the callback that we're going to pass in there. If those two conditions are met, then we have found the event that we want to basically unsubscribe for, right? We found the subscriber that we want to unsubscribe, right? So let me just put a comment here. Found the subscriber to remove. Let's just keep it simple. And then once we found that, we can do a size t j. I know we have a nested loop within a nested loop, but it's fine. Size t j equals to I, and then j less than entry count minus 1 j plus j plus plus. So j, how do I want to do? Okay, yeah, let's say event entry. Why I keep on confusing the names? Events, right? Then we want this event, and we want to say entry events. We essentially just moving things around here when we remove things, and then we just repositioning them and so forth. So I won't really explain too much of what's going on here, but yeah, that's what I'm doing. And do I guess we can. So let's say entry count less than entry capacity, divide that by 2. So we can shrink, right? Because remember, we have a function up here. Where is it? To resize, right? And this resize function essentially checks if we have one element. If we have 0 elements, then we basically create the capacity. We set the capacity to 1. However, if it's not equals to 0, then we take whatever capacity we do have and we multiply that by 2, right? So eventually we could have like 100 events registered, and when we remove 203 or remove 50, we have such a huge memory allocated that's not being used. So essentially we can deallocate that and shrink the array back to a normal size or whatever. So that's what I'm kind of doing here. So we can say optionally shrink the array if the number of subscribers is significantly smaller, and I made a typo, smaller than the capacity. Okay, so yeah, that's what we're doing here. So we can just say subscribe event, subscribed event, new events, basically following the same pattern that we used for the resizing. So subscribe, small events, reallocate. So subscribed, new events goes to reallocate, and we're just gonna pass in the entry events and the size that we want the new allocation to be. So we can just say entry count size of subscribe event. Okay, and then if new events, okay, or entry count is equals to 0, if it's equals to 0, then we can just say entry it's equals to new events, then entry capacity. I don't know, should I play music on my videos? But I don't think I should though, right? It will be distracting, I guess. But I don't know. I used to, but I guess music doesn't really play too well for these type of videos, I guess. I could be wrong, but yeah. Tell me in the comments if you think I should play some background music for y'all. Yeah, and then perhaps I should just put a comment here so that it's not confusing. So ensure successful or okay, that's about it. I'm realizing that I'm returning here, but it's a void function, so you don't need to return there. This return is taking us out of this if statement, right? Not if statement, but this loop essentially. So yeah, unsubscribed. So let's see if we broke anything. So that will work. Let's go back down to our main function. So we have subscribed to the pressed, moved, mouse moved. So I'm gonna call this twice, and you'll see that this gets called twice. This unmoved mouse callback gets called twice. So mouse moved, mouse moved. So what we want to do is, before we call it second time, we want to unsubscribe. So event unsubscribe. So we want to unsubscribe from this, and our listener or our subscriber, I guess, is that guy, and the callback is this. So we want to unsubscribe. So let's see if it gets called twice or once. So it gets called once. Beautiful. So our unsubscription works. We can unsubscribe from events. And notice once we unsubscribe from an event and we publish that event, nothing happens, right? This event doesn't even get called or published, because if there's nothing registered, we just simply return. But if there is something registered, then we call the event. So yeah, a little bit of efficiency there, I guess. So yeah, that's that. I don't know how long this video is, but that's it. Our event system is complete. In the next video, we're going to be setting up our input system, and we're going to hook that up to the event system, and then we're going to hook the input system to the platform layer, and we're going to get that to then essentially basically handle some input for us, right? So yeah, we're getting there. We are almost done with our platform layer, and then we're gonna close up Xcode, and we're gonna move down to Visual Studio Code, and then we're gonna set up our Vulkan renderer. So yeah, stay tuned for that, and I'll see you guys in the next video. Cheers.